Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 953. Please turn to it. Page 953, and today is our lesson number 139. Let's take a look at it. It has 4 questions, the 4 gradient questions, the last 4 gradient questions which are hard questions. Let's see what we can do there. Number 15. Question number 15 that we are about to do. Question number 15 that we are about to do. I would like you to compare this question. Compare this question with number 20 on page number 908. Something that we did on day number 130. Number 20, I believe it was the very last question in the section. Yes, it would have to be very last question. It's number 20. Compare this question, as I said, with that question. That question also deals with these problem deal with 30, 60, 90 triangle. They both deal with the same concept, and I hope that you will pause this video, watch that one first, because in that video on day number 130 I covered in detail as to what's going on with 30, 60, 90 triangle and how to remember it. We have a mnemonic device for it. Mnemonic device that we use to keep track of the different sides in a 30, 60, 90 triangle is very straightforward. There are 3 different angles, 30, 60 and 90. There are 3 different angles, so we put down 1, 2, 3. And once we have put down 1, 2, 3, take the very last one and put a square root sign on it. That's it, we are almost done. All we have to do now is to plot our 30, 60, 90 triangle. This one doesn't look like it. Here's our 30 degrees. The side facing the 30 degrees is the smallest side. Here is our 90 degrees. And the side facing the 60 degrees would be this side in the middle. So now we have to arrange them in order. 1 is the smallest one, 2 is the largest number, root 3 is the one that falls in the middle. Therefore, the side facing the 60 degree, which is side facing the 60 degree, which is this side, would be root 3. Side facing the 30 degrees, which is this side right here, would be 1. And the side facing the 90 degree would be 2. There is your 30, 60, 90 triangle. And you have to be able to reproduce this thing in a hurry in the exam. Once we have that part, the rest is downhill. Let's take a look at the problem. Here we are told that in the picture above, EBCD is a square. So let's draw it here. Here is a B, C, D, E. We are told that it is a square, which means all of these 4 sides are equal. They go on to tell us that this triangle that we see here, this is 90 degrees. They tell us that it is given. It is 90 degrees. They also tell us that this is 60 degrees. Well, if this is 60 degrees and this is 90 degrees, the remaining is 30 degrees, which means we're dealing with a 30, 60, 90 triangle. And they tell us that A to E, this is the part where you have to pay attention, A to E is 8. A to E is 8, which faces 30 degrees. The side that faces 30 degrees, the side that faces 30 degrees is 8, which is this side right here. So this is 1 here. If you make this 8 times as much, this becomes 8. This will be 8 times as much, and this will be 8 times as much. So this will be 8 times as much. And those are our 3 sides. In other words, the side facing 60 degrees is 8 times root 3. The side facing 60 degrees, this side right here, which is 8 times root 3. And it's a square. It's a square where B to E we just found out is 8 times root 3. And the question simply is, what's the area of this square? Or how do you find the area of a square? The area of the square is this side times this side, which is also 8 times root 3 because it's a square. So area of the square, BCDE is simply equal to 8 times root 3 times 8 times root 3. 8 times 8 is 64, and root 3 times root 3 is 3, and that's it, we're done. That's it. 60 times 3 we know is 180. You see, we're doing this part here. 64 times 3, let's do it here. 64 times 3 is same as 60 times 3 plus 4 times 3. 4 times 3 is 12. 60 times 3 is 180, so it's 180 plus 12, which is 192, and that's our answer. But the key here is finding out the side of the square. The side of the square is 8 times root 3, and how do you know this is root 3? Because it's a 30, 60, 90 triangle. In a 30, 60, 90 triangle, the sides come in this proportion. The sides come in this proportion. 1, root 3 and 2. 1, root 3 and 2. 1, of course, is the one that faces the smallest angle, which is 30 degrees in this case. Then the 60 degrees, which will be facing the root 3, the side which is root 3, and the side that faces 90 degrees, the longest side, which is 2. And that's it. Let's do the next one, shall we? But as I said before, already 2 or 3 times, watch that problem number 20, and you will appreciate how this notion of 30, 60, 90 degree triangle can come up in a very hard problem. Number 20 was a very tough one. Number 16. Let's finish it up. Number 16, the next one. Number 16. By the way, in a 45, 45, 90 triangle, this is 45, this is 45, and this is 90. Here we only have 2 types of angles. 45 and a 90. There is only 2 types. Since there are only 2 types, we write down 1 and 2. Same exact technique. Then we put a square root sign on 2, and then we arrange these numbers in order. Well, they are already arranged. One is smaller than root 2. So 1 faces 90 degrees because that's the largest angle here. So it will face this, 90 degrees. So the side facing 90 degree would be the larger number, which is root 2 rather. And 1 here will face 45 degrees and 45 degrees. Just like we did for 30, 60, 90. For 30, 60, 90, here's the technique. 30, 60, 90. There are 3 kinds of angles. 30, 60, 90. There are 3 kinds of angles. So we write down 1, 2, 3. Put a square root sign on the last one. Arrange them in order. 1 is the smallest one, then root 3, and then 2. 2 faces the largest angle. The largest angle is 90, so that's 2. 1 faces the smallest angle. The smallest angle is 30, so it's 1. And 60 will be the one in the middle, which is root 3. There you go. There's your 30, 60, 90 triangle, and there is your 45, 45, 90 triangle. Next one. In a mixture of peanuts and cashew, the ratio of the weight of peanuts to cashew is 5 to 2. How many pounds of cashew will there be in a 4 pounds of this mixture? So they start out by talking about peanuts and cashew, but the punchline, what they're asking here is not comparing peanuts and cashew, but it's comparing peanuts versus the mixture itself. So in this situation, peanuts and cashew, they are in a ratio of 5 to 2. What this tells us is that for every 7 pound of mixture, or rather in every 7 pound of mixture, we have how many pounds of cashew? in every 7 pound of mixture, we have 2 pounds of cashew. So that implies that in every 1 pound of mixture we will have 2/7 pound of cashew. Of course, whatever this amount was, we take a seventh of it, because instead of 7 pounds we have 1 pound. And the question here is, how many pounds of cashew will we have in 4 pounds? So therefore in 4 pounds of mixture, we will have 4 times as much. That's it, which is 8/7. And that's our answer, 8/7. So that's one way of doing it. Another way we could have solved this problem is to set it up as a proportion problem. Cashew versus the mixture. Let's do that. Cashew versus mixture. Cashew versus the mixture. And we know that every 7 pound of mixture has 2 pounds of cashew. The question is, what would happen if we only have a mixture which is only 4 pounds? If the mixture is 4 pounds, how much cashew will it contain? That's all it is. And again, all we have to do now, is cross multiply. Just cross multiply, so we get 2 times 4, or rather 2 times 4 equals 7 times x. We are interested in finding out the x. So multiply both sides by 7. 7 cancels out, and x equals 2 times 4, which is 8/7. Same as before, obviously. So that was number 16. Number 17 and 18, the last two on the next column, we'll do tomorrow, okay? I'll see you tomorrow, okay? Bye now.